Okay, we're going to move on to area bounded by curves, which is chapter 6. Basic concepts here are if you want to find the area between two curves, you just find the area of the top one between it and the x-axis, and you find the area of the bottom one between it and the x-axis, and when you subtract those two things, you wind up with the area trapped by the middle of them. We've done similar problems probably back all the way in Algebra 1, but probably you use things like a rectangle inside of another rectangle or a picture frame or something like that. So again, if the function, and I'm literally talking the one farthest away from the x-axis as the top one, is g of x, and this function here is f of x, they intersect at a and b. These are x values. Then the integral would be from a to b, lower bound to upper bound of the intersection of the top function minus the bottom function. This is how you find area that's trapped between these two curves. So your steps over here would look something like this. Step one, find the points of intersection. One way to do that, probably the best way to do that, is just set the two functions equal to each other and solve for x. Sometimes you might use your graphing calculators, and if you remind me, we'll have to get practice on that because sometimes they'll give you problems that you have to get a little better at finding intersections using graphing calculators. After you find that, those x values of intersection, they are the lower and the upper bounds. So then you just take the top function, and again, we're talking the one which is farthest away from the x-axis, and you subtract the bottom function from it. So we'll start off here with an example of g of x is equal to x squared and h is x is equal to x cubed. If I set them equal to each other to find points of intersection, I pull everything to one side. I wind up factoring x squared times 1 minus x is equal to 0. So that means x is 0 and x is equal to 1 are the 2 points of intersection. These are x values. So I use these as the bound. 0 is the lower, y is the upper bound. And then I take the function that's on top. And I didn't know which one was on top, so I plugged them in. If I plugged in a half and I squared it, I got a fourth. But if I plugged in a half and I cubed it, I got an eighth. So it must be the case that g of x, which is x squared, is on top. So I set up the integral, top function minus the bottom function from 0 to 1. Antiderivative rule, or I'm sorry, anti-power rule for integration, and f of b minus f of a, and we wind up with 1/12 for the area trapped there. Another thing that they might throw you a couple of curveballs on, or sometimes they give you an area which the top and the bottom functions change. In this case, we've got area bounded by y equals rad x, which is basically this area to here. The straight line y equals negative x plus 6, which goes down through here. And they want you to evaluate this from basically from 0 up until 6. So what we really have to do here is we have to separate this into two different areas. The area bounded by A is between 0 and 4 of just rad x. Notice there was no lower curve to mess with here, so we didn't have to. And the upper one was from 4 to 6, and that one was of negative x plus 6. So sometimes you have to separate the integrals based on what's their top or what's their bottom. You have to be careful of what kind of functions define the area. Okay, so again, if we do rad x here, uh, actually, if I want to do some of the work, I actually set rad x equal to negative x plus 6 to find the points of intersection. And when I did that, I wound up with x minus 9 and x minus 4. So x is equal to 9 and x is equal to 4. X is equal to 9 would be where they intersect down here somewhere. And since we're not looking at that bottom part of the graph, then x is 4 was the one I was going to use. And then we just split the integrals. We did the antiderivative, the inverse power rule twice. And when we got done, we added the two areas together and we came up with 22/3. And about the last thing that we'll work with here is if they give the functions in terms of y. And I should have probably done this with the Elmo so I could turn this thing sideways. But basic concepts are now you're looking at y values. So we're looking at 1 as the lower value. And I'm sorry, 1 is the upper bound, and we're looking at negative 2 as the lower bound. So again, these are y values. And the upper function, this time we're going to look perpendicular to the y-axis. So the one farthest away is this one, the 3 minus y squared. And the one closest one is the y plus 1. So again, you kind of got to look at this thing, tilt your head to the right and look at it that way. Top one here, this is the lower bound at negative 2. It's a y value. This is a y value, which is the upper bound at 1. So I set the two things equal to each other. I solve for y. They give me the bounds. Once I do that, I now take the top function, 3 minus y squared, minus the bottom function. Don't forget to distribute to negative. And then again, we're just going to take the integral with most of these, again, are just power rules. So I take the integral, I do my f of b minus f of a thing. As you can see, I even had a little mistake here once before I was moving on. And you finish up. areas. I think we're going to work on the odd problems today. I think it's like 1 through 27, but here are some of them. Feel free to slow it down, stop it. Try one or two would be fantastic. And we'll hit these probably Monday in class. Thanks.